This is Unit 8, Area and Solids. Preview video 8.2, Area of Regular and Irregular Shapes. Sit tall. Close your eyes. Inhale. Deep breath, hold. And exhale. Keep your eyes closed. Let's do that one more time. Inhale. Hold. Exhale slowly. You should have your preview notes handy and a calculator. Preview notes, calculator, obviously. Pen and pencil and some colors would be very, very helpful. Don't forget date, time, and location. Quick review. During class, we talked about the area of the quad family tree. Quick recap. Parallelogram. The area, whole area, is going to equal the base, which would be either one, times height. Remember, height always creates a right angle. Height always creates a right angle. Area of a rectangle, also. Area equals either length times width is what was commonly understood. Length times width. But of course, because the width creates a right angle, we could also call this base times height as well. Base times height. Rhombus, area equals, you must have this memorized, one diagonal, diagonal 1, times the other diagonal. And remember, the diagonals are at right angle, diagonal 2, diagonal times diagonal over 2. A square, length times width would be the area is side squared, but remember a square also qualifies as a rhombus as well. So you could also do diagonal 1 times diagonal 2 over 2 for a square as well. Trapezoid is the average of the bases, since there's now 2 of them, the average of the bases. So base 1 plus base 2 over 2, average of the bases, times again the height, which creates a right angle. Kite, same as a rhombus because the diagonals are perpendicular, diagonal 1 times diagonal 2, area equals over 2. This is the area formulas for the quad family tree. Knowing this, I want you to attempt this page on your own. Pause the video, restart when you're done. Pause. Okay, welcome back. Hopefully you actually did the work versus just copying. That's important. You learn to use your own brain. I'd rather this be incorrect and then you correct it in red pen than simply copying. Step number 1, you should have drawn a rhombus, which means all 4 sides are equal. Has a side length of 5 feet. That's going to be all the way around 5 feet. The longer diagonal, we're told, is 8 feet. Find the area of the rhombus. So you always start with the equation. And your equation is the first diagonal times the second diagonal over 2. Diagonal times diagonal over 2. But what you should have noticed is that you were missing a diagonal. So this would be 4 and 4. You got a right angle here. Once again, you have a right triangle. And we want that little piece right there. That's a 4. That's x. That's 5. Leg squared equals hypo squared. X squared. And you should have gotten this length to be 3, which means this length is 3. Now you have everything you need. So your one diagonal is going to be 8. Your other diagonal is going to be 6 over 2. You can take the 2 into the 8 or the 6. It doesn't matter. I'm going to take it into the 6, get a 3. And your area is going to be 24, let's check, feet squared. Very important, correct your work, write a note of what you did incorrectly or what you overlooked. For today, we're going to talk about regular polygons. That should ring a bell. We've done regular polygons before from Unit 6. First, we're going to recap our triangles. So we're going to start this by recapping area of triangles very quickly. As a quick reminder, triangles are half parallelograms, so they're base times height over 2. And in an acute triangle, the height is inside. So watch this diagram. So those are all acute triangles. In a right triangle, the base and the height become the legs. And in an obtuse triangle, the height goes on the outside. So an acute triangle, the height is in. A right triangle, the height is on, thus constituting the legs. And in an obtuse triangle, the height is outside. So in drawing this right here, I'm going to squiggle all the bases. That would be the base. That would be the base. That would be the base. So the area would equal base, this is your base, times your height, straight down, right angle, base times height, over 2. In an obtuse triangle, the area would equal the base times the height. In this case, the height is outside, meeting an imaginary extended line, over 2. And in a right triangle, the base is actually one of the legs. So leg 1 times the height, which is simply the other leg, leg times leg, over 2. That's how you find the area of an acute, an obtuse, and a right triangle. All of them are essentially base times height over 2. Quick recap, the area of a right triangle area of a right triangle is 6 centimeters squared. So let's just draw what we have here. We have the area, which is 6 centimeters squared. It's a right triangle, so immediately we're going to write our equation as leg 1 times leg 2. The longer leg is 4 centimeters. We want to find the length of the hypotenuse. What could we do with that? That is ultimately our x. Let's look at what we can do. Obviously, we need this right here as well. We're going to call that just the other leg. Circle, plug, chug. Our area is 6 centimeters squared. Our one leg is 4. Our other leg is unknown, over 2. Solve. Now, the question did not ask what the other leg is. It asked for the hypotenuse, which in this case would be have two sides, need third side, Pythag. So 3 squared, 4 squared, unknown squared. Our hypotenuse would be 5 centimeters. Ask yourself, if you were to have done this by yourself, which of these steps might you have overlooked? Would you have overlooked writing out this equation? Would you have overlooked the fact that 3 was not your final answer? Would you have overlooked the necessity of using Pythagorean theorem? I'd like you to star which of those steps might have you overlooked. Let's do one more. This one I want you to try on your own. Pause the video, then restart. Welcome back. Let's see what we have here. The area of an obtuse triangle. So we're going to draw ourselves an obtuse triangle. And the area is 72 centimeters squared. Area equals base times height over 2. It says right here the height is 6 centimeters, so that's 6 height outside. Find the length of the base. There's your unknown. We'll call it x. Circle, plug, chug. That 72 goes right there. Base is unknown. The height is 6 over 2. I'm going to take the 2 into the 6 and get 3. So I have 72 equals whatever the base is times 3. And we get the base is 24 centimeters. Again, identify, if you didn't get that correct, which step might you have overlooked. Let's recap what a regular polygon is to begin with, because the rest of the lesson is going to be based on a regular polygon. The shape to the right is regular. I'd like you to trace it. You notice you have all congruent sides. By implication, it also means you also have congruent angles. So you have congruent sides and angles. Keep in mind what you're about to learn in the next 15 minutes only works for regular polygons. Does not work for anything else. Only polygons that meet these two circumstances, congruent sides, congruent angles. Let me introduce, there's a couple new terms here. So in a polygon, there is going to be a center, just like the center of a circle. So that would constitute the center, of course. And in this case, the center would be A. Now, radius. In a regular polygon, a radius connects center to corner. A radius connects center to a corner. A radius connects a center to a corner. And you'll understand why it's called radius. Imagine a circle circumscribed about the regular polygon, and the center of that circle is a radius, and the radius of that circle is also going to be the radius of the polygon. A radius goes from a center to corner in a regular polygon. Here's the new term, an apothem or apothem, I'll use that interchangeably, goes from center to midpoint of a side, and the apothem bisects the side, and makes a right angle. So the radius goes from center to corner. The apothem goes from center to midpoint of a side. You need to know the difference. So over here on the left, let's do an apothem first. Center to midpoint of a side, right angle, bisect, that would be an apothem. And from center to corner, that would be a radius. You need to know the difference. Now, whenever we work with regular polygons, I always want you to physically trace the perimeter. Always. Whenever you see a capital P means the perimeter. I want you to physically trace when you find it. Physically trace. So, for example, the perimeter on the left, trace it. Go around like that. Notice there's 8 sides. So we walk it around. Our perimeter is going to be 8 times 8. In this case, 64. If you're not given any units, perimeter is singular units. So we're just going to write 64 units. Here, again, physically trace, count. 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 sides times 10.2 each side. Don't you dare grab a calculator for that, friends. Come on, you can do your 4th grade math longhand. Please don't get lazy and use calculators for this kind of stuff. It's going to be 18, carry the 1. 9 times 0, that's 0 with the 1. 9 times 9. So we get 91.8 units. Physically trace your perimeters. Always physically trace your perimeters. Let's recap. The area of a triangle is half a parallelogram. And half a parallelogram is going to be base times the height over 2. That is the area of a triangle, half a parallelogram. We're going to use a triangle to build for a regular polygon. So keep in mind that area of a triangle is basically going to be base times height over 2. You're looking at this page. I'm 1 page ahead. Give me just a second here. So the area of a triangle, let's carry that over. Area of a triangle is the base times the height over 2. Base times height over 2. So take a close look here. In a regular polygon, it is essentially made up of a bunch of triangles. That's why the regular polygon equation is related to a triangle equation. So it's multiple triangles. There's your base of one triangle. Ready? Trace the base of the next. Base of the next triangle. Keep going. Base of this next triangle. Base of that triangle. Base of this triangle. Base of this triangle. So instead of finding the triangles individually, we're going to add up all the bases, which is basically your perimeter. So we're going to replace the word base with perimeter. The height of a single triangle, center, right angle, is actually the apothem. Therefore, area equals base times height over 2 for a triangle, for a single triangle. But if we wanted to do all of these triangles in a single equation, all we have to do is replace base with perimeter, height with the apothem over 2. And this, my friends, is how you find the area of a regular polygon. Area of a regular polygon, perimeter times apothem over 2. Pa over 2. Regular polygon is pa over 2. Let's do some examples together. So right here, area of a triangle is base times height over 2. A regular polygon is perimeter times apothem over 2. So we're going to come over here. We're going to find the area of the following. And we're going to write the equation. Area equals perimeter times apothem over 2. And in this equation, our perimeter, it's 10.2 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So our perimeter is going to be 9 sides times 10.2, that's our perimeter, times our apothem, which is 14 over 2. I'm going to reduce to make this easier to work with. Without a calculator, I'm going to take the 2 into the 14 and make that 7. From the previous 10, 9 times 10.2, that's 18, carry the 1, that's a 1, and that's a 9. So I have 91.8 is my perimeter times 7. And you get 642.6. Check for units, no units, units squared. Some of you are a little paranoid that I did that without a calculator, so we'll show this on the calculator. We're going to go 9 times 10.2. There's our 91.8 times 14 divided by 2. Looky there, folks. Yes, you can manage without a calculator. Ready right here. Let's do another problem together. Says a regular hexagon, hex, 6. So we're going to start with drawing this. We're given the area 680.4 centimeters squared. A single side length is 16.2 cm. We want to find the apothem. Always start with writing your equation. Area equals perimeter times apothem over 2. Our perimeter is going to be 6. Six sides times 16.2 times our apothem that we don't have. That's going to be our unknown. So we're just going to call it A over 2, but we've been given the area, 680.4. We're going to solve from there. There's a couple ways you can do this. You can just cross multiply. I'm going to take the 2 and reduce that 6 to a 3. And from here, yes, you can use a calculator. All right, so we are going to do 3 times 16.2. You get 48.6, so I have 680.4 equals 48.6 times the apothem. Of course, you divide that out. $680.4, divide out 48.6, and we get our apothem is 14. Check for units, cm. If there's units in your problem, there needs to be units in your answer. This page, you're going to do completely on your own. Yes, you may use a calculator, but show your work. Restart the video when you're done. Okay, students, welcome back. Let's see what you did here. Perimeter area equals perimeter times apothem over 2. So you trace your perimeter. We're going to go 5 times 16, that's your perimeter, times your apothem, which is 11 over 2. You should at least have this set up. 5 times 16 times 11 divided by 2. You should be getting 440. No units provided. You should just designate units squared. This one. Area equals perimeter times apothem over 2. Walk it around. 1, 2, 3, 4, 5, 6, 7. 7 sides times 11.3. That is your perimeter. Your apothem, 11.7 over 2. Decimals are always okay. If you get a decimal, just round it to the tenths place. That's 462.7. Check for units, no units, so it's going to be units squared. There is a lot to memorize for this unit, a tremendous amount. So I have something here that might prove helpful in helping you memorize. So right here, the area of a rectangle, length times width. And a parallelogram, base times height. A triangle, 1/2 base height. A trap is half height, sum of bases. Half height, sum of bases is the same as average of the bases times the height. If you look up in a textbook, this would be the given equation. This is the equation I taught you in class. I think it's more simple. The average of the bases times the height, half height times the sum of bases, those are equivalent equations. An area of a regular polygon is 1/2 perimeter times apothem. You're like, is this a song? Is it not a song? And lo and behold, yes, you should recognize these little notes here. It is a song, friends. This goes to The Ants Go Marching One by One. A camp song. The ants go marching one by one, hurrah, hurrah. The ants go marching one by one, hurrah, hurrah. The ants go marching one by one. The little one stops to suck its thumb, and they all go marching down to the ground to get out of the rain. Boom, 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 or some sort of variation of that at some point. You had a camp experience. And I'm going to do a little bouncing ball here, and we're going to sing this. And you're going to remember all of these equations. Ready? I'll slow it down. The area of a rectangle, length, width, and a parallelogram, base height. A triangle, 1/2 base height. The trap is half height. Sum of bases and area of a regular polygon is 1/2 perimeter. Apothem. Boom, boom, boom. The area of a rectangle, length, width, and a parallelogram, base height. A triangle, 1/2 base height. The trap is half height. Sum of bases and area of a regular polygon is 1/2 perimeter. Apothem. Boom, boom, boom. All right, friends. Summarize what you have learned in today's lessons in your own words.